Assalamu alaikum, dear students. Welcome to the lecture of the nuclear physics. In this lecture, we will discuss the basics of the nuclear physics, and we will start from the types of the forces, the basic four fundamental forces which exist in the nature, and then the particle which are responsible for the mediation of that forces. The very common forces and the very weak forces is the gravitational force, which is very famous because of the its extensive range, which is the gravitational force. It is weak, but it is range is so great, larger, because of it is very prominent among all of the forces. And the second is electromagnetic forces, and the third is the weak interaction force, and the fourth one is strong interactions. So, what are the particles which are responsible for the mediation of that force? Gravitational force exists between the two, for example, objects because of the exchange of the gravitons, and the electromagnetic force exists because of the mediation, because of the exchange of the particle which is known as photons between the two particle. Actually, these photon exchange between the particle, and this force is responsible for the existence of the electromagnetic force. And the third one is weak interactions, which is lepton. Lepton, Greek words which means swift and very light particles. So it's mediate the weak interaction force. And the another fourth type is the strong interactions, which is mediated by the hadrons. Hadrons are strongly interacting particles, and its interaction time is very small. We will discuss in detail in the coming slides. Strong interaction. The hadrons are further divided into two categories: gravitons, photons, leptons, and hadrons. These are the responsible particle for the mediation of these four forces. Hadrons are further classified. You can see from these diagrams that we have stable elementary particles, gravitons, photons, and then leptons and hadrons. Hadrons are further classified into two categories: mesons and baryons. Then baryons are further classified into two categories: nucleons and hadrons. We will discuss one by one all of these forces: gravitons, photons, leptons, hadrons, and then mesons, and then baryons, nucleons, and hadrons. And we will also discuss those particles which are coming in these categories. So, mesons and baryons, because hadrons are classified into two: mesons and baryons. These mesons have masses intermediate between muons, mean micromesons, and nucleons, and baryons include nucleon and the particle heavier than the nucleon known as hadron. All of these classes of particle are shown below. So in the coming slide, we will discuss that what are the particles which come in the categories of the nucleons, then what are the particles which are coming in the categories of hadrons, and then definitely if some particles belong to categories of nucleons or either hadrons, these will come in the category of baryons. And we also will discuss the difference between the mesons and baryons. Okay. Another thing is antiparticle. All elementary particles pair have their antiparticle. An antiparticle is a particle having the same mass, same spin, and lifetime if unstable, but its charge has the opposite sign, and the alignment or anti-alignment between its spin and magnetic moment also is opposite to that of the particle. Means if we have a one particle and its antiparticles, both will have the same mass, same spin, and lifetime, but just the nature of the charge will be the opposite and equal in magnitudes, and the alignment or anti-alignment between its spins or the magnetic moments is also opposite to that of the particle. Means alignment and anti-alignment means spin and will be also magnetic moment will be an opposite to that particle. So We will also discuss the antiparticle of all those about discussed particles. Okay. Similar particle antiparticle pair are, for example, electron. The antiparticles of electron is positron, and similarly, pi meson and pi negative mesons are antiparticles. Proton and antiprotons, neutron and antineutrons, neutrino and antineutrino. These are the antiparticles, which we will now discuss in separate sections also. The very first particle, graviton, which are responsible for the gravity forces. Graviton, the particles graviton, which is supposed to give rise to gravitational field and has happened to and yet not been discovered, which cannot be discussed, which cannot be observed on the laboratories in the laboratories. And the second is photon. Photon has zero rest mass and no charge. Its mass is h mu over c square, and its energy will be just equal to h mu, and mu is the frequency of light. And its angular momentum is 1 h cut. It means its angular momentum is 1 h cut. It means integral multiple of h cut. It follows Bose-Einstein statistics. It is not subjected to spontaneous decay. It means photon is stable particle. Photon have electromagnetic attraction. Means photon can be produced by the annihilation of electron-positron pair. If two electron and positron annihilate, they produce gamma rays of photons, because gamma rays have no photon, no charge. And the third one is lepton. The class of elementary particle include light particle with mass that of pion, pi meson, and these particles are responsible for the mediation of the weak forces. So the three lepton and their antiparticle are electron and their antiparticle positron, very first, and the muon, negative muon and their antiparticles neutrino and antineutrino. There are two types of neutrino, electron neutrino and muon neutrino. Similarly, and their antiparticles will be like electron neutrino and muon neutrinos. The first neutrino is associated with beta decay. It is called electron neutrino, and mu is associated with the muon decay. Okay, these are the some leptons, electrons, and its corresponding in neutrino, and these are its antiparticle, electron and its corresponding antiparticle, a neutrino and its antiparticle. Similarly, muons and its antiparticles, mu neutrino and its antiparticle. Similarly, tau particle and its antiparticle, tau neutrino and its antiparticles. These are the spin. You can see that it's all half integral spin particle. It means they follow Fermi-Dirac statistics. And then another category, hadrons, which are strongly interacting particles, which are responsible for the mediation of the strong nuclear forces. These are divided into two categories, mesons and boron. Hadrons are divided into two categories. The first is meson and the second is baryon. Okay. Hadron, meson, and the second is here baryon. So meson, these includes pion, k particles and eta particles. Meson are divided into further three categories, pions, k particles and eta particle. Pion is a short name for pi meson. There are three types, means it can exist in the three charge different state. The first is positive ion, negative pion and neutral pion. These are can be written with pi plus, pi minus and neutral pion. Similarly, k particles, they can exist in the three different types, three different states. positive cation, negative cation, and neutral cation. And the third category is eta particles. The third meson, which is eta particle, it is no charge, rest mass 1073 times the mass of electron, and half-life 10 power minus 18 second. These are the further classification of the mesons. And then, because hadron is divided into two, meson, we have discussed the meson, that meson divided into pion, k particle, eta particle. And another is baryon. Baryon is further divided into two categories: nucleons, and second is haprons. Baryon is divided into two: nucleons and haprons. Okay. Now, baryon is divided into further two categories: nucleons and Hebron. Okay. Baryon, nucleon. These include proton, neutron, and their anti-particle, mean anti-proton and anti-neutron. All these have spin h/2 and obey Fermi-Dirac statistics. You know that proton has positive charge and its mass 1836 times that of electron. It has spin h/2 and magnetic moment 2.793 of Bohr magnetons. It is stable particle but can decay inside the nucleus as follow. You know that proton is unstable inside the nucleus and convert into neutrons like this. Proton convert into neutron. Its anti-particle is anti-proton. Another particle is neutron. It has no charge but mass equal to 1839 times the mass of electron. Its spin is h/2 and magnetic moment is minus 1.9 times Bohr magneton. A free neutron decay with half-life of this according to this equation. Neutrons, free neutron is unstable and it can convert into protons and also antiparticle. So these are the types of the nucleons. Okay, nucleons contain two particles. Nucleons contain two particles, proton plus neutron. Okay, and then another is haprons. In this group lie the particle of mass greater than those of nucleons. Haprons are those particles which have mass greater than those of nucleon. They have spin h/2 except the omega particle which has spin 3/2 and obey Fermi-Dirac statistics. The various particles are given below. You can see at this tables. Then these are the actually baryons. These all are particles. Okay, if I go back into previous categories, hadrons. Okay, these all particles are hadrons. Says that hadrons, and hadrons is divided into two categories: mesons and baryon. Okay, hadron is divided into two categories: meson and baryon. Meson is further divided into three sections: this, and this. It can exist in the three different charge state. You can see that pi minus, pi plus, and this. And cation can exist in three different states. You can see. Similarly, eta particles and its antiparticles. Similarly, baryon is further divided into two: nucleons, and I will say these for all particle haprons. Okay, these all are haprons. Nucleons is further divided into two particle: proton and neutron, and it also its antiparticles. And similarly, haprons are lambda particles, sigma particles, xi particle, omega particle, lambda particles. Okay, it can exist in the one charge state. Sigma particle can exist in the three different charge states. You can see sigma 0, sigma plus, and sigma minus 1. Similarly, xi neutral and xi negative, and also its antiparticles, omega, and omega its antiparticle. So these are all lambda, sigma, xi, omega are haprons, and proton, neutron are nucleons. And similarly, meson is divided into three category pion, kayon, eta particle. Pion can exist in the three different charge states, and kayon can exist also in the three different charge states. And similarly, eta particle can exist in the uh, one neutral states and its antiparticle differently. It is the antiparticle of itself, like neutron and its antineutrons. So some particles are antiparticle of themselves. So these are the categories of the nuclear particle or elementary particles, and these are the spin of all of the particles. You can see that mesons have zero spins, and baryons have h cut over 2 or 3 h cut over except omega particles, which has been 3 over 2, and these are strangeness. You will discuss it in the later lectures. So I will stop at this point, and we will meet again in the next lectures.